Hello and welcome everyone to my class on Kubernetes. Now, just wanted to quickly cover exactly what you can expect from this class. So this class is pretty much for a complete beginner. But that being said, it does cover a lot of in-depth things, as well as goes into a lot of detail where I think a lot of classes actually fall short. So I would think even an intermediate person would be able to glean a little bit of information from this class. That being said, it looks to take you from absolute zero to maybe not hero, catchy name, but more like it looks to take you from absolutely zero Kubernetes knowledge to being competent in Kubernetes. If you're looking at taking the CKA or the CKAD, this class should be very close to getting you to a really good starting point for those exams. And I look to then further expand on this class as time goes on to give you much more advanced topics as well. What is Kubernetes? This is a question you may have asked. If you are here, you might already have kind of a slight idea, but I'm going to start from the very beginning as I don't know where each one of you are starting from. Feel free to skip to wherever it becomes interesting for you, though I do warn you again, I do go into depth on many things, and you might learn a thing or two even if you already know a little bit on a subject. So let's start from the very beginning. Kubernetes is what a whole lot of people call a container orchestrator. Now, I would be tempted to argue this is incorrect on a technical level, but this is an acceptable start. Now, why would we want to orchestrate containers? As we well know from our container lessons, containers brought us this concept of immutable infrastructure, or at least part of immutable infrastructure. It also brought us isolation of workloads. So containers give us the ability to repeatedly spin up the same process on any server we want, while also ensuring that our workload does not interfere with another workload. This is really awesome, and in the context of microservices, where we can have multiple of the same process running, solves a lot of issues. But if we're going to do this, it means a lot of processes need managed. Not only that, but you probably want hardware level redundancy. So if process X is not all running on process Y. In such a failure of a machine, this would bring down all the running processes of process X and leave you in a failure state. So in the end, we can either hire a fleet of interns to continuously check on our application, fix all the errors, and start running new processes, all while updating network configurations to ensure that wherever these new processes are created, other ones can access them, all ensuring that our process runs in a distributed way, none of them overlapping on different machines, as well as all accessible from the network. Or we could use a tool to do this for us, and this is where Kubernetes comes into play. Now, while Kubernetes looks to solve these issues, and maybe a few others, letting you seamlessly schedule and run containers across a fleet of machines, scaling and auto-healing, and enabling you to expose those services to other services, it brings with it its own set of issues that can only be solved by knowledge, just like most issues. Kubernetes simply clusters a group of servers and runs containers on those servers. Now, it provides other tools like deployments, replica sets, and services, but all those tools are built around helping you manage these containers, or like we learned in the containers class, isolated repeatable processes, all running on a wide range of different servers. So very simply, at a very high level, Kubernetes runs a cluster of servers. It does this by running a control plane on a small group of servers, usually 3 to 7. And these servers manages and maintains what is running and where. And everything else will run on these machines will be containers that you make through the Kubernetes API. This way, if those machines go down or if one of the containers crashes for some reason, Kubernetes will work to stand up another container running the same process, either on the same machine or another machine altogether. Not only does it help with failures, but it can help with scaling and things like this when you have designed an application to scale horizontally, as it can schedule additional containers if needed. Now, if you don't understand what horizontal scaling is, it's when you scale by adding more servers, not by migrating to a larger, more powerful server. This would be vertical scaling. Now, let's cover really quickly what Kubernetes is not. I find it really helpful to have a good understanding of what something is not so that we have a better understanding of what it is. Kubernetes is not a one-stop shop to fix all your deployment issues. It's not simple. It brings all of its own issues. It does not suddenly make your application scale horizontally. You actually have to program your app to scale horizontally. Not only this, it requires you to design your apps in such a specific way to run in a specific manner. It's not your solution to infrastructure. It does not bring an easy developer experience. And lastly, it is not a one-stop shop. It is the base that a lot of things are built on top of. Not only does Kubernetes add yet another abstraction layer between your development team and the systems that it runs on. This means either your developers need to understand Kubernetes, or you need to build and maintain the infrastructure to abstract this away from your developers. This is a lot of work. It can slow down development, cause massive errors, and even downtime if not dealt with properly. I don't say this to scare you. I really don't say this to scare you or tell you I think it's bad. It's not. I say this because too often I see people who misunderstand the issues it solves and attempt to fix problems it doesn't fix, while giving themselves larger and more painful issues. So, Kubernetes is a scheduler, one mainly focused on containers. We can extend it to manage VMs, but we'll focus on containers. Now, while it uses immutable infrastructures for its pods and containers, this does not mean that it itself manages your infrastructure. The fact is, you are just starting your infrastructure pain when you start using Kubernetes. Kubernetes itself is a group of services that run on a cluster of machines. Maintaining and securing those machines, as well as ensuring Kubernetes itself is up to date and patched, along with ensuring every base container image that you use in your fleet of applications is patched and up to date, is still your responsibility. Now, there are cloud providers that provide services to handle some of these issues, and they are awesome and your friend. But understand, these are additional features in the managed solution from the cloud providers. This is not base Kubernetes functionality. Kubernetes doesn't manage your infrastructure. It schedules pods and containers. Kubernetes doesn't have a public-facing load balancer. This is provided to you by your cloud provider. These are not features of Kubernetes. These are features of the cloud provider. I want to ensure you understand Kubernetes is not for everyone, and not everyone can benefit from adopting it. If your application is a monolith, if your application does not scale horizontally, or if you have a small team that does not want or need the added complexity, Kubernetes is probably not for you. Microservices are a technique for management of software teams, not an end-all be-all. If your team does not know Kubernetes and you don't have the resources or the time to train or hire a team to abstract it away from said developers, Kubernetes is probably not for you. If your team is small and wants to focus on their application, Kubernetes is probably not for you. If you are struggling to scale and think Kubernetes is going to solve this with no changes to your application architecture, Kubernetes is also probably not for you. There are a lot of other things you can use if any of these scenarios happen to be you. If you think Kubernetes solves your multi-cloud or observability issues, let me assure you, it does not. Kubernetes can help with multi-cloud, and it can be a strategy for your multi-cloud deployments. But it's just one piece of the puzzle and requires architecting your app and other things to be multi-cloud. Kubernetes, if anything, makes observability harder. Now, there are some tools out there that help and build things just for this inside Kubernetes and make observability in Kubernetes easier. But it is not solved by Kubernetes itself. It's solved by tools built for Kubernetes. The only problem Kubernetes solves, and the one that it does really well, is the ability to schedule pods and or containers. You'll learn more about pods later. While it can be used to solve other problems, these are not the problems it was designed to solve. Now, there are projects out there like Harvester to make HCL out of it, Istio for service mesh, or Vector to increase visibility. But you must understand these are projects built on top of Kubernetes, and they are using it as a tool, as a means to schedule containers that they need. And to be honest, most applications in their own right use the control plane to be highly available and offer an HA service that does these things. Kubernetes itself does not do these things. And don't be mistaken. The Kubernetes ecosystem and community are massive, and one of the reasons to adopt Kubernetes could be the fact that it has a fantastic ecosystem and community. I just want to ensure that you understand what Kubernetes itself is and does. Let's have a quick technical description of Kubernetes to wrap up this lesson. If I was to try and summarize Kubernetes into a single sentence to describe what it does, I would have to say Kubernetes is a collection of services to form an application to provide highly available and resilient scheduling system for groups of related containers called pods. Now, it accomplishes this by leveraging things like etcd, gRPC, container runtime, think Docker, and JSON or YAML. Kubernetes itself is a collection of microservices that can be run individually or on the same machines as the other components. All right, so with all of this talk about what Kubernetes is or is not, let's get on with understanding Kubernetes nomenclature and then start building our very first cluster to use and experiment with. Please join me in the other lessons I have made and learn about Kubernetes with me. If you like this video, please go ahead and give it a like and subscribe to this channel to support me in making more educational content for you.